wanted to talk through a few problems in this test review for Unit 8 that I think just need a little bit more explaining. Hope that's okay. Thanks for popping on. And even in May, you're still caring. That's what's up. Much appreciated. You're awesome. What's happening here? We have this. I don't want to say this is considered a parent function, but part of me does want to say this is a parent function or adult at home function. So these are points that we're trying to work around, and we're being asked to describe these newer functions, which may use what's called this geometric notation, which you saw in 8.1, where we were comparing all these newer transformed functions to the parent function. And you also saw this in 8.1. So I wanted to just talk about this. So this is saying that you're taking your original XY coordinates and what are you doing to them? This is saying that you want to take whatever X was before and deduct 3. So if it was originally 0, you should be thinking out what's 0 minus 3, which hopefully you're saying is -3. Here you would think X coordinate here is 2. So what's 2 minus 3? That's -1. So on and so forth. We'll just run through these real quick. And what's this now saying for the Y coordinate? Saying you just want to multiply the Y coordinate by 4. So if the Y coordinate here was 1, 4 times 1 should just kick you back a 4. 3 times 4 kicks you back 12. 7 times 4, 28. 4 times 13, what's that? 40, and then you add on 12, so 52. And finally, this is 5, and 4 versions of 21 is 84. So this is the new g of x function. And again, you saw this in 8.1. Here, what's happening here? This, I believe, was referred to as relationship to the parent function notation, which is saying that we definitely want to double y, like double the whole outcome. But this right here is what you really want to hunker down on. Because although you may think, oh, I just add 1 to x over and over, I'm going to give you a throwback because you've seen this as x squared as a parent function. But then when you saw this, what was that transformation like if it was now parentheses x plus 1 being squared? Hopefully you're saying that that moved everything to the 1. Or yeah, it moved everything to the 1. It moved everything to the left 1 unit. So think about that, because you're taking all your x coordinates, and if you move them to the left 1 unit, you're deducting 1 from them. So that means that this should be 0 minus 1. It's -1. 2 menos 1. 1. 4 menos 1. 3. 5, 7. Hope that makes sense. And then this one's not too bad because you're just doing 2 versions of the outcome respectively. So 2 times 1 is 2. 2 times 3 is 6. 2 times 7 is 14. 26, 42. Hope that makes sense for this one. Again, if you're stuck on this, I would look back at what you did in 8.1, comparing functions to the original parent function. I think if time permits, I'm just going to do every other problem or so. This is f composed with f of x, and we're being asked to write and simplify each composite function. So don't leave any loose ends of things that could be rewritten. So I know that at the core of this, f of x, this middle f of x, I can rewrite it with that, which is saying that I'm putting 2x squared minus 3. I'm putting that into another form of f of x, and f of x is this. So if you've seen Inception, I think this will all make sense, but it's as if you want a function inside of a function, and sometimes even that's inside of a function. So at a quick glance, notice what happened here. Because originally f of x was this, right? You had some argument being squared and then minus 3. And I did just that right here. And so how can I simplify this further? You have 2 versions of this being squared. So order of operations says use the exponent first. So this is really going to be, you're foiling now. two versions of this trinomial, which is 4x squared minus 6. Oh, sorry, my bad. 4x to the fourth. I'm not trying to end up in the YouTube description saying that I messed up foiling, right? And definitely not with the arithmetic, because yes, this should be minus 12x squared. And then plus 9. So this is the foiled out version of 2x squared minus 3. If you're not convinced, try it out. And then if we really want to simplify this further, distribute that 2 and get what? What would you get? I'd get 8x to the fourth minus 24x squared. 2 times 9 is 18, but then deduct 3, so this is plus 15. Let that sink in for a moment. This is the most simplified way to write your answer. I'm hoping that you're able to achieve the same thing. For the next problem, I'm choosing to do problem 4, which is g of f of x, which is really evaluating g of this 2x squared minus 3, because again, at the core of this is f of x. If you're not convinced, check the instructions. So if you take all of this and put it in place of this x for g, you end up with the following. And I use parentheses whenever I use composition of functions, because I think of it as like a quick copy and paste instead of x and putting in all of this. So this is a pretty decent answer. It's fine, but what would you personally simplify further? Hopefully you're saying that these 3's can cancel, because even though this is parentheses, you can drop them. And then you end up with evaluating square root of 2x squared, square root of 2, that can chill, but square root of x squared, I'm really hoping that you can take that further to just x. Hope that makes sense. My strategy for this, look into the middle, think about what you're evaluating. Don't be afraid to rewrite it like this. And I think parentheses will set you up to be successful for this, especially if you have some exponents that are lingering or a number in the front that eventually needs to get distributed. Don't forget your order of operations here, because that's a big deal. This is another number game. So at the core of this, you're evaluating g of 3. So g of 3, this is light work. You've been doing these little evaluations since integrated 0. This should kick back, what, -6 minus 1, so -7. So really at the core of this, you're evaluating f of -7, which is 3 versions of -7 being squared, and you're adding 2. So this is really 3 versions of a positive 49 plus 2. And this is what? 147 plus 2. So being 49, that's your answer. And then at the core of this is f of 1. F of 1 is going to be 5. If you're not convinced, try it out. And then g of 5, this is light work. Legit, just integrated 1, plugging and chugging again. So -11. Sound good? Beach, look into the middle, evaluate what's there. Those aren't too bad. These problems, I imagine, are the ones you're going to want to practice, because you're doing a composition of rational expressions. And the domain's a big deal, because you're going to end up with actually 2 values that are going to be excluded. So at the core of this is m of x going in place of this x for h of x. So let's write out this whole shindig. Use parentheses here for sure. And so one of your values is definitely going to be the root of this denominator, which is what? Well, the root of this x plus 6 is going to be -6. So that's the one value you want to say you don't include. So all real numbers with the exception of x can equal -6. And then channel your unit 5 skills and simplify this denominator. So this is like kind of a cross multiplying ordeal. Keep the 3 up top. If you cross multiply that, you end up with all of this. But now you have 4 multiplying with x plus 6. I kind of jumped a step here because I'm assuming you know what you were doing in unit 5. You can then distribute the 4. So now if we rewrite this, this is 2 plus 4x plus 24. That's all over x plus 6. What can you simplify here? Well, you're saying the 2 and the 24. So you can say that this is 3 dividing by this fraction of 4x plus 26. And this is all over x plus 6. And this is the tricky part. So believe it or not, this is a division of fractions. The whole problem is because you have 3 and you're dividing by this fraction. So get ready because this is a safe move. You can say that your top's just 3 over 1. And that's multiplying with what? What do you think? Hopefully you're saying the reciprocal of the bottom fraction, because that is what it is. This is division of fractions, you know what I mean? So you can say that this is approaching a more simplified 3 parentheses x plus 6 over 4x plus 26. And so this is like the most simplified composition. And so let me actually, I don't want that answer there. So that's not the answer we want. But as you can see, this takes a lot of space to work through them. And so now you have another term that you want to exclude from your domain. And it's really just the root of this. So if you set that equal to 0 and solve, this is one of those problems where you would have not been able to guess it. So please make sure that you put in the work to solve what's here. And eventually you see that x is this negative 26 over 4. And so this is the second value you want to exclude from your domain. So it's all reals except these two, negative 6 and negative 26 over 4. Capiche? This multiplication of them, I don't think that's going to be too bad because what, you're just multiplying them, right? So I don't know if too much is really going to change, but I'll entertain it real quick. I don't know if the order, yeah, my order is pretty good because these are multiplying. This isn't a composition. Please look at that closely. So really you can say that this is 6 divided with the same factors from before. And what were the roots of these factors? This is me just sketching out the domain. Hopefully you're saying that x can equal negative 4 because that's the root of this, and negative 6 respectively. And heck, why not? While I'm here, I'll even throw some interval notation at you because I know that you're capable. And that's a union between negative 6 to negative 4 because negative 4 is a little bit bigger. And then union with negative 4 to infinity. So I guess let me know which of these you prefer to write. Are you more of this talking domain or more interval notation talking domain? Personally, I think that the first one's easier. I hope that this makes sense for the domain problems here. Get some table work here. This is, your eyes may go cross-eyed at some point, but don't let that happen because I don't think these are too tough. The core of this is saying evaluate g of 0, which is 2. And then the outside, this is saying evaluate it in f. So f of 2, what is that? It's tree. At the, let's do 14. This is the sum of the two. A few people were confused on this notation, but this actually is just saving you some writing. When you see this sketched out, and x is 3. So get that right, Cortez. There you go. Now you're cooking. So this is saying just find f of 3, which is 4, g of 3, which is 0. 4 plus 0. Last time I checked with Siri, the answer is 4. This is just going to be multiplying those outcomes. So this is f of 5 times g of 5. 3 times 2 is 6. This is evaluating g of h of 3. H of 3, we see here is 1. So it's really saying evaluate g of 1. It's just 3. If that makes sense for those. I don't think those are too bad. You did a problem like this in the quiz review and also on the quiz, actually. So I'm not going to talk about that because you've done it before. There is one typo here in this problem, that the function here should be 3r plus 1 because it's 1 more than 3 times the radius. Long story short, you're filling with this. What is this? The level of water in a conical cup is a function of that. So the height, or no, this is like cubic. So this is volume. So it's talking about some height in this conical cup. Guess I'll draw it because I'm here and I'm capable. And there's water. The water's purple. You have these two functions. And mean as to find the volume of water in a cup as a function of the radius, which is really saying that you want the volume, but you only want it to deal with variables of r. And maybe this is squared, maybe this is something else, but that's what this is saying, is that as a function of the radius, it's really saying you want to find the volume, but you only want r to be the only variable that's in the mix. So in my eyes, this is talking about the height. And I know that the height's being talked about here. So isn't it safe to just say that V of R is going to be the composition like this? So 1/3 still pi, still r squared, but instead of height, use 3r plus 1. And does this match? Is this just finding the volume based off of what r is? I think so. So we're using this to directly calculate the volume in the cup when r is 2. So this is pretty light. Just plug and chug. So this is really saying what's v of 2. It should be 1/3, same as it ever was. Pi is same as it ever was. Those squared with parentheses of 2r plus 1. So 2 times 3 is 6, plus 1 is 7. So this is 1/3 pi times 4 times 7, which is 28. And so at the core of this, you could say that this volume is going to be 28/3 pi. And do we have units? No. So you can say that this is units cubed. Hope that makes sense. Sketch the product of the two, some points that you should get. Take a moment, see what points can you find that are pretty decent, and I'll make a table to show what's happening with them. So in the middle, these are some points that I thought were pretty decent. On the way right, this is the points that would work for that f of x times g of x, which again, you might also see denoted as f dot g of x. So these are all points that you can use. The function ends up using these 5 points in the middle, which is kind of interesting, but there's actually a little bit more that it does. And so long story short, if you end up graphing out the rest of these, I think you end up with something like that. You could also note that these little moments, every even number, it's going to be 0. So that's actually kind of helpful, because you can assume that this is going to be pretty consistent. And what it does in between is kind of crazy. I invite you to graph out a little bit more, but long story short, you end up with something like this. And you see it bounces quite a bit. I think it actually may cut through. I don't know if that's exactly how that works. There may be some higher peaks that it goes to, but I invite you to sketch out some of those. But that's kind of what I'm aiming for, is that this should definitely swoop in, do something like that. It may cut through at some point, so I invite you to try those out. I think this one actually may cut up to, what is it, 3-3? Well, long story short, you only need 5 points, so just get 5. I hope that this helps. If you have any questions, reach out. Talk soon. Be safe. Take care. Brush your hair.